Okay, Denzel, this is the explanation to this question you did. You know, this question, this cubic question, they don't usually put cubes in because it's so much algebra, it's so much work. So it's an unusual question to get in an exam. But still, it's probably good to understand it and the basic thing to understand it. When you started this question, you start f prime of x is equal to the limit as h approaches zero. H approaches zero. There's an h missing. I'm not sure why, because the whole thing is this h on the bottom is getting closer and closer to zero, and it's a gradient. It's f of x plus h minus f of x. Well, f of x is given. If you see f of x in the formula, you rub it out and you put 2x cubed minus 3x squared plus 5. That's what it is. But f of x plus h means wherever you see an x, you've got to replace it with x plus h. So there's f of x. F of x plus h is exactly the same as f of x, except instead of x, there's an x plus h. So it's x2 times x plus h cubed minus 3 times x plus h squared. And there's a 5 added in the f of x, so you've got to add a 5 in the f of x plus h at the end. Okay, this is what it's long and kind of hard. This is what it looks like. Here's f of x plus h, and all it is f of x, but with an x plus h there. Now the problem is x plus h cubed, you've got to work it out, and it looks like you did that right. You did work it out in later kind of problems, but I couldn't go back and actually look at this because if you make mistakes in the first part, everything just goes a bit crazy. So you have to get the first part right. Well, x plus h cubed turns out to be x cubed plus 3x squared h plus 3x h squared plus h cubed. Just like h plus h squared is x squared plus 2xh plus h squared. Now, all I've done is just work that out. And in this part, there's a negative here and then a bracket, and it'll change the sign of all these things. Minus 2x cubed plus 3x squared, and then minus 5. Then all I did was multiply the 2 by everything, and multiply this minus 3 by everything. And then you see this stuff in the blue, it will all cancel. 2x cubed minus 2x cubed minus 3x squared plus 3x squared plus 5 minus 5. Ooh, everything got a lot simpler. Now, I think I like seeing that there's an h in everything. You factor it out and put it in front of the bracket. Now, h multiplies by all of these 6 things to equal the 6 things that are here. I actually took an h out of everything. Now you're ready to get your answer. The limit of the h is no longer in the bottom, so we can now let h approach 0. 6x squared plus 6xh plus 2h squared minus 6x minus 3h. Well, if we let h approach 0, the 3h, the 2h squared, and the 6h xh will all become nothing. And what you'll end up with is the limit as h approaches 0. In fact, it's called the derivative. The derivative of this whole function is 6x squared minus 6x. Now we learned this shortcut, and to see, does the shortcut work? If we go back to the original function, 2x cubed minus 3x squared plus 5, all we do is we go 3 times 2 is 6, and then we subtract 1 from that 3, 6x squared. 2 times minus 3 is minus 6, and subtract 1. Hey, that should be the derivative. Now, this gives us the rate of change, the change in y with the change in x, for any x value along this function. It turns out that it's a cubic function, and we can now get the gradient anywhere we want. The key thing in the beginning is you have to write the function down exactly the way it is, and f of x plus h is exactly the same function, just an x plus h there. You still have to write the 2, the x cubed, all the other stuff, you have to write it the same. So if you mess up the first step, unfortunately, the next 20 steps all mess up. I hope this helps. I hope it helps. Because I'm sending it to you now, and I think somebody else might like it too, because it's one of the harder questions, and it's probably pretty good to explain to everybody. I don't know. I like making it. It was fun. Okay. Bye.